Hey guys, so this is the third and final video for reviewing equations and which equation to use from your reference table for solving titration and like the more mathy problems for our acid-base chemistry unit. So far we've already gone over numbers 1 and 2, so we're going to continue with number 3. So it says how many moles of OH minus hydroxide ions are present in 1 liter of 0.5 molar sodium hydroxide. So it's only talking about one substance. It's only talking about a base. There is no mention of combining it with an acid. So we will only be using equation number 1. So our equation is molarity is equal to moles over volume in liters. And so we're just gonna, oh, I wrote that in the wrong spot, shoot. Okay, there we go, because we're doing number 3. So molarity equals moles over volume. And again, this equation can be using to describe an acid or a base. In this case, for number 3, we are using it to figure out moles of a base. So we're just going to plug in the information that we know. It tells us we have 0.5 molar solution, so I'm just going to write 0.5 over there, and it's in 1 liter. So in place of the volume, I am going to put 1 liter. And so we're just solving for moles, and to get that variable by itself, I'm going to multiply 1 liter onto each side. And 1 liter times 0.5 molar is the same thing as saying 0.5. So 0.5 moles of hydroxide, sodium hydroxide, is how many moles of ions that are present. So yeah, we just used equation 1 because we only had one substance. And that's it. For number 4, how many moles of H plus ions are needed to completely neutralize 1 liter of 0.5 molar NaOH? So this is actually like the same challenging question that we had in number 2, and I'm going to do it more quickly this time because we've already done it before. So the key thing is that equation number 3, because it has Ma times Va, that's like saying moles, right? That's like saying molarity times volume. That is equal to moles. So this equation is really telling you that when you have moles of an acid equal to moles of a base, you have neutralization happening. So we can again go about this 2 different ways. I felt like after showing you guys it was kind of easier to think about it first in terms of equation 1. So they tell us that we have 1 liter and 0.5 molar sodium hydroxide. So if I use equation 1 with that, I have oh, that's the same thing as what we just solved for in number 3. So we already solved for how many moles of sodium hydroxide we have. We found out we have 0.50 moles of NaOH. So if we're trying to neutralize it with H plus ions, again, based on equation 3, your moles of acid has to equal your moles of base. So if you have 0.5 moles of base, that means that you're going to need 0.5 moles of acid, or 0.50 moles of, you could just say H plus. That means acid. So again, numbers 2 and 4, they really use both equations, so they're challenge questions. So because 5 is similar to 2 and 4, I'm going to give you a question where it's clear that you would just be using equation 3 by itself. So if I gave you a question that said, I have a 2 molar solution with 1 liter of HCl, how many liters of calcium hydroxide do I need to neutralize? And I have to specify the concentration. And I'm going to say it's of, let's say it's, I don't know, 1 molar. Nah, let's go with 3 molar. Okay, so I have 2 molar acid, and I only have 1 liter of it. And I have 3 molar base, and I'm trying to find out the volume. So we don't know the volume. So this problem, even though I worded it kind of weirdly, sorry about that, this problem, it's clear to me that I need to use equation 3 because I'm talking about an acid and a base, and I have molarity and volume, and this has molarity and volume of the acid and the base. So I'm going to start off by writing the equation. NMA and VA equals NMB VB. My first step is to figure out N for the acid. So if I look at my HCl, each hydrochloric acid molecule has 1 H. So your N for HCl is 1. For my N for my base, each calcium hydroxide has 2 hydroxides. I know that because there's a little 2 here. So my N for my base is 2. So in this equation, I'm going to put a 1 on the acid side and a 2 on the moles for the base side. So here's my 1 and here's my 2. Okay, then they tell me, so I have my concentration and my volume for the acid, so I'm going to just plug those in on the acid side as well. Oops. So let's do that. So I have 2 molar acid and I have 1 liter of it. And then we don't know the volume of the base, but we know its concentration is 3 molar. So I'm just going to plug in the concentration for the base. Again, we don't know what the volume is, that's what we're solving for. So, to get VB by itself, you need to move these to the other side. So I am going to, because it's being multiplied, I'm going to divide 2 times 3. Which, I mean, we might as well just combine it and say 6. So I'm going to divide by 6, and I'm going to divide it by 6, because they're multiplied, 2 times 3 here. So when you do that, this is now left that side. So 1 times 2 times 1 divided by 6. Well, let's see, 2 divided by 6 is 0.333. So our volume of our base is 0.3 repeating. And that's in liters. So Notice how for this problem, it was clear that we used equation 3 because there was information that had molarity and volume and molarity and volume for both acids and bases in that problem. Yeah, hopefully that helped clarify when to use and how to use these two equations. And if you have questions, just email me. Okay,